everyone. Today we're going to talk a little bit more about implicit differentiation. Our goal for today will be to use implicit differentiation to find the slope of the tangent and normal lines. So we know that we find the slope of the tangent and normal lines when we use the derivative. So we first need to find dy dx, or the derivative. Once we find the derivative, we can plug in the x value of interest to find the slope of the tangent line, and then flip and negate that slope to find the normal line. So let's go over implicit differentiation one more time. So we're going to take the derivative of each of the pieces, and then we're going to make sure that if we have the derivative of y, we write dy dx. So the derivative of 2x is nothing other than 2. The derivative of 9y is nothing other than 9, but since we took the derivative of y, we need to multiply this by dy dx. Now, if you take a look at this next term, negative x squared y, we have a product rule where negative x squared is my high and y is my low. So if you remember the product rule, it's low d high. The derivative of negative x squared is negative 2x. So we just did low d high plus high and d low. So the derivative of y is nothing other than dy dx. And then we keep going. The derivative of negative 1x is negative 1. And the derivative of a constant 10 is just 0. So we don't need that. So I'm going to clean things up a bit here. I have 2 plus 9 times dy dx equals negative 2xy minus x squared times dy dx minus 1. So I want all dy dx terms on one side. So I'm going to go ahead and highlight the dy dx's in green. So this needs to be on one side and this needs to be on one side. And I'm going to highlight all the other terms in red. So this 2 and negative 2xy and negative 1 need to be on the same side. So I'm going to keep the green stuff and I'm going to move it to the left. So I have 9 times dy dx, and I'm going to add, right, because there's a negative x squared, so I'm going to add this x squared dy dx to the other side, and now I've got an equal sign. So I already have on my equal sign, I have a negative 2xy and a negative 1, so those can stay. So negative 2xy and negative 1, but now I need to join it with this positive 2. So if I'm moving the 2 to the right side, I'm subtracting it, so I put a minus 2 there. And now I have all my dy dx's on one side, so I can go ahead and do what we did yesterday and make dy dx my GCF, and 9 plus x squared goes on the inside equals negative 2xy minus 1 minus 2. And to get dy dx by itself, I'm going to divide by the 9 plus x squared, and I would divide it over here. So again, you don't have to write it, you can just write the result. So negative 2xy minus 1 minus 2 over 9 plus x squared. And you actually can also combine like terms. I didn't see this earlier, but this negative 1 minus 2, we could have done that and we could have actually made it 3. So whether you do that ahead of time or not, that's your choice. So I'm going to do that now. So I have dy dx equals negative 2xy minus 3 over 9 plus x squared. So this is my dy dx. Now remember, dy dx, the derivative, is the equation for the slope of the tangent line at any given x value. Okay, so dy dx is my derivative or my slope of the tangent line at any given x value. And you can tell this problem wants to find the slope of the tangent line or lines at x equals 2. So we actually have to go back down to what I got for the derivative, and we're going to plug in x equals 2. But there's something that you should notice, and you should notice that the x value, we can plug in 2, but I'm missing a y value. And if I want to find the slope, I need a number. I need it to come out to a number, not something including y. So with these types of equations, we're actually going to have to find the y value first. So what we're going to do is go to the original equation, and we're going to find the y value. So step 1, plug in x equals 2 into the original equation. And we need to do that so that we can find y. So I'm going to just rewrite it. We've got 2x plus 9y equals negative x squared y minus 1x plus 10. So I'm going to go ahead and plug in 2 for x. And I'm going to leave y alone. And let's see if we could solve for y. So we've got 4 plus 9y equals negative 4y minus 2 plus 10. So 4 plus 9y equals negative 4y plus 8. All I did was combine those. I'm going to add 4y to both sides. So I get 4 plus 13y equals 8. And to get rid of this 4 here, I'm just going to subtract 4 on both sides. So I get 13y equals 4. And divide both sides by 13. And I get y equals 4 over 13. Okay, not a pretty number, but it's okay. So this is the value for y, and x is the value of 2. So in my derivative now, my step 2 is I'm going to plug in x and y. So plug in, I can even make it a point, 2 comma 4/13 into dy dx to find slope of the tangent line. Okay, so we have dy dx equals, now I'm just reading from here, negative 2xy. So negative 2, x is 2, y is 4 over 13, minus 3, all over 9 plus 2 squared. So take a minute, type this whole thing into the calculator just the way you see it. Make sure you're using the fraction button. If you're unsure how to do that, you can ask me in class tomorrow and I'd be happy to show you. All right, pause the video until you've got an answer and then hit resume when you're ready. Okay, so I got that my derivative, or my slope of my tangent line, is negative 55 over 169. So this would be my slope of my tangent line. Now, I know they could ask you the slope of the normal line, so the normal line slope would just be this flipped and negated. Awesome. Let's try another one. Okay, so what I actually like you guys to do right now is pause the video and just start by doing the implicit differentiation, and then we can do the other part together. We can find the slope of the tangent line or lines at x equals 2. Okay, here is your work for what you should have got for the implicit differentiation. All right, so we're going to now use this information to find the slope of the tangent line at x equals 2. So just like we did before, we need to find the y value because our derivative has y's in it as well. So we're going to go to the original equation. So we're going to plug x equals 2 into the original to find the y value. Okay, that's step one. So just like I did before, I'm going to rewrite the equation. I have x squared y squared equals 3y plus 1. So I'm going to go ahead now and plug in 2 for x. So I have 2 squared y squared equals 3y plus 1. So I have 4y squared equals 3y plus 1. And to solve for y, I'm actually going to have to get it by itself because, or bring it equal to 0 rather, because I have a y squared. So I can make this 4y squared minus 3y minus 1 equals 0. I'm going to do a little guess and test here to try to factor this. So let's try 4y and y and 1 and 1. You could do the AC method if you'd like, if you want to pause the video and try to see if you get the same thing that I do. So this is 4 and this is 1, and I need it to add to a negative 3, so I'm thinking minus 4 and positive 1. So then my solutions are 1 and negative 1 4. So what happened in this scenario is that we actually have two different y values. So when x is 2, y is negative 1/4, and when x is 2, y could also be 1. So that means that this thing is a curve, x squared, y squared. So this x value of 2 could share two different y values. So in this case, there actually would be two tangent lines that we could make at x equals 2. So let's find the derivative or the slope of the tangent lines for both different lines, right? So we're going to do the same thing as before, but now we're going to find two slopes. So we're going to plug in these points to our derivative. So plug in points to dy over dx. So let's plug in our first point. So my first point we'll say is this one, 2 and negative 1/4. So dy dx equals, now I'm just reading from here and plugging in x and y. So 2, the y value is negative 1/4 squared times my x value of 2. Bottom is 2, my x is 2 squared, my y is negative 1/4, and then minus 3. So take a minute, pause the video, type that into the calculator, and then hit resume when you're ready for the answer. Okay, I got negative 1/8 to be my slope. So this would be the slope of the tangent line. And we could call this tangent line number 1, right? Because we've got it at this point. So now we'll plug in this point to find the second tangent line. So let's go ahead and do that. So now we have another dy dx. And this time x is going to be 2 and y is going to be 1. So 2 times 1 squared times 2 over 2 times x squared y minus 3. So go ahead, pause the video, type that into the calculator, and then hit resume when you're ready for the answer. Okay, so you should have gotten 4/5. And that is the slope of the tangent line, which we'll call the second tangent line. So tangent number 2. All right, that's it for today. If you have any questions, now's a good time to jot them down and let me know tomorrow. All right, have a good night.